So here we go. Um, so one of the first things you got to get in both micro and macro courses, you got to know what the factors of production. Okay, and if you think about those words, factors of production, it's the things that are used in the production of other things. And everything uses these factors of production. They may not use all four, but pretty much everything does use all four, but they may not. So I'm gonna go through the four factors of production, and you may hear these things also called as resources. Throughout the semester, you'll read something and it'll talk about the resources. They're talking about the factors of production. They'll talk about the factors. They're talking about the factors of production. They'll talk about the factors of production. In fact, one unit that you'll be doing is called the factor market. It's an entire unit on these things and how many units you should hire and such things like that. So here we go. So there are four factors of production, as I said. The first one is land. Land tricks people because when you think of land, you think of, a field out there or what have you. But land is not only the land itself, but all the natural resources that come from that land. So oil is land, unprocessed oil is land. Trees are land. Fish are land. The ocean is land. Anything that comes natural from the earth is considered land. Now, once it's processed, like for example, oil that we pour in our car didn't come straight from the ground, it was processed. It's actually no longer a factor of production. It's what we would call an input. An input is something that you use, and the very first time when you use it, it's done. It's used up. Okay, where the factors of production are not that case. You say, wait. If I cut down a tree, then it's used up. Yes, but when you cut it down originally, it is considered land because it's out on the sorry, my phone just went ringing. I want to fix that up. Anyways, so the tree is still considered land, and once you cut it down and start using it as lumber, then it becomes an input. So the second factor of production is labor. This is you and me. Labor is workers. It's the worker bees. It's all people that are involved in the production process except for the owner. The owner is what we call an entrepreneur, and that's the fourth factor of production. You need to be careful the difference between labor and human capital. Human capital is what makes workers better. Okay, it's the investment in people. Right now, you're taking an AP class. Why are you taking an AP class to the regular econ class? Because you want to build on your human capital. You want to get ahead of others. You want to have it look better on your resume. You want to get the college credits. You can take other classes. But education is not the only way to build human capital. Healthcare, taking care of yourself, being healthy, good nutrition, job training, punctuality, showing up with a smile on your face, all that stuff that adds to the workforce and makes you more desirable over one worker over another is what is human capital. So you've got labor, then you've got human capital. The factor of production that we're dealing with is labor, but later on we're going to be talking about capital, which is machines and tools, things like that. I'm going to do that next. But then there's human capital, which is investments in labor. Okay, which brings us to the third one. The third factor of production is capital. Capital is think machines and buildings, as I put here. Think machines and buildings. So, for example, if I start a company and I'm making pens, I need a factory. That's capital. I need the machines to produce the pens. That's capital. I need a truck to deliver my pens to whoever they're going to be. That's capital. So it's anything that's used in the production process that's not land or labor. It's the machinery and that sort of stuff. So computers would be capital. A smart board in a classroom would be capital. That sort of stuff. Okay. One of the big gotchas here is that money is not capital. Money is not capital because money in itself is useless. Okay, money is useless. It's you can burn it for heat for a very short period of time. Money is used to buy land. Money is used to buy labor. Money is used to buy capital. Money is used to buy land, labor, and capital. Okay, so anyways, and then the last factor of production is the entrepreneur. The entrepreneur is the owner. He's the one or she's the one that takes the original, the land, labor, and capital, the original three factors of production we talked about here, and puts them together to start a business. Okay, that's the entrepreneur. The entrepreneur is responsible for Starting business, the entrepreneur is the one who bears the risk. They're the risk taker. And because of that, they're the profit seeker. A lot of people are, badmouth profits. They badmouth profits. And they talk about these CEOs of these corporations making millions of dollars and how terrible that is. No, it's not terrible. That's the market. That's the market. They're the risk takers. They're the ones that are going to lose everything if that business goes under. They're the ones that deserve the profits for starting that business. Um, you know, Maybe they are making lots and lots and lots of money, but that's what the market will pay. And if the market wouldn't pay that, then they wouldn't get paid that kind of money, right? And so, anyways, so there's your four factors of production: land, labor, capital, entrepreneurship. Moving on to the next concept. All right, next concept we're going to talk about is called the production possibilities curve, also known as a production possibilities frontier. Um, you'll also see this is abbreviated, and abbreviations in this class are acceptable provided they're like you're not making up your own abbreviations. All right. For example, PPC is production possibility curve. PPF is production possibility frontier. Those are both perfectly acceptable when you talk about them here. In fact, the EK, the essential knowledge that you have to know, actually says the PPC. Production possibility curve is a model used to show trade-offs associated with allocating scarce resources. So let's stop right there. What do we mean by scarce resources? Scarce meaning there's not enough of them. Okay. What is there not enough of? Resources. What are the resources? Land, labor, capital, and entrepreneurship. You say, wait a minute. There's lots of labor out there. There's lots and lots of labor out there. No, there isn't. There is not enough labor to produce everything that society wants. Okay. Now, sometimes we don't use our labor effectively. We don't allocate our labor in an efficient manner, and that's when you have unemployment. When you have unemployment, it's because your labor is not being used efficiently. But when labor is used efficiently, you have shortages of labor. There's not enough of it. There's not enough land, labor, or capital out there to produce everything that everybody wants. And that's where this production possibility curve comes from. Okay. And because of that, because there's not enough to produce everything we have this thing called trade-offs and opportunity costs. So let me go into these guys here. Trade-offs and opportunity costs, some vocabulary words here. An opportunity cost is your next best alternative. What you give up is your opportunity cost. So right now, you're listening to this video. Well, what could you be doing instead? Well, you could be playing a video game. You could be sleeping. You could be hanging out with your friends. Now, if I just listed three things, if I just listed, hang with your friends, video games, or sleep, let's say that's your three things that you might be doing if you weren't watching this video. Those three things are called trade-offs. Those three things are called trade-offs. But if you said to me, and I said, well, which one of those three would you be doing? Well, I'd probably be sleeping. Well, that makes sleeping your opportunity cost. There can only be one opportunity cost. There's an opportunity cost, a singular opportunity cost. There can be many trade-offs. Okay, and everything in society has opportunity costs and trade-offs. Everything has an opportunity cost or trade-offs. Me doing this session right now, there's an opportunity cost. Earlier, I went to Home Depot and I had to buy stuff for materials for my greenhouse, right? Well, by using that money to buy something for my greenhouse, that means I couldn't use that money to buy something else. And that's the thing. And so decisions have to be made. Okay. So the shape of the PPC depends on whether the opportunity costs are constant, increasing, or decreasing. Okay. And I'll show you these. And when I do, then you'll understand what these mean. Okay. So this is what we would call a constant opportunity cost PPC. Now, a couple things about this. It's actually not a PPC. And the reason why it's not a PPC is because it's not labeled. All graphs have to be labeled. Notice the PPC is a solid line. I remember in my introductory session, I said dotted lines are not considered curves. The production possibility curve, if you drew this as a dotted line, if I came over here and I drew it like this, it would not be acceptable. It has to be a solid line. It has to be labeled as PPC or PPF, or you can write out the words you want to production possibility curve you want. The other thing is the axes have to be labeled. So, let's say we're talking about good Z and good X, then now it's labeled. The numbers here, you don't have to have, because the straight line production possibility curve tells you that it's a constant opportunity cost. When you have a straight line production possibility curve, that means it is a constant cost going on there. So that's constant opportunity cost. I put the numbers in there just to show you what the cost is, okay? So what way this works is, let's suppose we're down here. That means we're producing 6 units of good B and 0 units of good A, because that point right there is 0, 0. So we're producing 6 units of good B and 0 units of good A. What if instead we're way up here? Well, we're producing 12 units of good A and 0 units of good B. And what happens is, as we slide down this production possibility curve, and this is not, it's not very well drawn, because that should have been 12 and 0, yeah, 10 and 1. It should have been 10 and 1. So just the way I drew, I drew this by hand. So this point right here is 10 units of A. Okay, this I'll do it in green. This green dot is 10 units of A and 1 unit of B. So what did we give up to go from 0B to 1B? We went from 0 to 1. What did we give up? We gave up 2 units of good A. We went from 12 to 10. What if we go the next step? What if we go here to 8 and 2? When we go to 8 and 2, we gain 1 unit of B. What do we give up? We give up 2 units of A. What we say there is the opportunity cost for 1 unit of B is 2 units of A. The opportunity cost of each unit of B that you gain, every time you go this way, every time you gain 1 unit of B, you give up 2 units of A. A is the opportunity cost of B. Okay. What if we went the other way? Well, then for every 1 unit of A that we gain, we give up a half a unit of B. So, but since it's a constant, 2 for 1, 2 of A for 1 of B, 2 of A for 1 of B, 2 of A for 1 of B, it's constant. It doesn't change. That was what we call a constant opportunity cost. If we had an increasing opportunity cost, I don't know why I don't have this graph here, but if we had an increasing opportunity cost, then let's go ahead and do, again, we'll do good X and Y, okay? This would be bowed outward. Okay, and when you watch the lesson on this, you'll see they'll talk about this. This is what we call an increasing opportunity cost. And the way this works is, when you first gain a unit of Y, you don't give up much X. But as you gain the next unit of Y, you have to start giving up more, because this thing's bowed out. You have to start giving up more of X. And when you get another unit of Y, you have to give up even more of X. And what will happen is, this will actually you'll start giving up more and more as you slide down this thing like that. That's what we call an increasing opportunity cost. You give up just a little bit to start with, then more for the next unit, and even more for the next unit, even more for the next unit. This looks a lot better, and you can see it a lot better when you actually have numbers to apply with this. And when you actually go through the unit, they'll apply numbers to it. But I just wanted to tell you the concept of what it is. Okay, so we've got an increasing, we've got a constant opportunity cost, we've got an increasing opportunity cost. The last one I want you to be aware of is what they call a decreasing opportunity cost. This one here, up until 10 or 12 years ago, we didn't even say that this existed. Let's say we've got, let's say we're producing 2 goods. So we're producing butter, cars. Okay, this economy, this factory, this country, this state, this whatever, could produce either butter or cars. Okay, that's a terrible one to use for decreasing opportunity cost. Sorry about that. Because let's stick with X and Y. And the reason why is the butters and cars definitely do not have a decreasing opportunity cost. Okay, so they definitely do not. So let's stick with X and Z. Okay, a decreasing opportunity cost is one that's going to be bowed inward like this. It's going to be bowed inward. This is goods that have a lot of technology associated with them. Let's suppose that Verizon comes up with the ability to do 6G. I don't know if it's out there or not. I don't know anything about that stuff. But you say Verizon has the ability to do 6G. They've come up with that technology. And the person who puts that all in the Verizon company decides to leave and go work for AT&T. Does Verizon lose that technology? And the answer is no. It's already out there. But then AT&T can gain from it. So when you have a decreasing opportunity cost situation, it's one that what happens is that you actually don't lose by trying to produce more. So what you end up getting is both AT&T can produce more and Verizon, they're going to produce a little bit less because of the they lost that worker, but they're not going to be it's not they're not giving up anything. So um, in my knowledge, they've only asked this one time on an AP exam. It was a multiple choice question about 3 or 4 years ago. It could show up this year, but all you need to know is for decreasing opportunity cost that in order to gain one unit, in this case, in order to gain a unit of Z, at first you give up a lot of X, and then you gradually give up less and less and less of X. That would be a decreasing opportunity cost. So, all right, new topic. Oh, no, not a new topic. Okay. Production possibility curves can shift. Okay. One of the things we're going to find about this class is there's always shift happening. There's even an expression out there. People will say it all the time that shift happens. I was, in my school the other day and I heard some freshmen say shift happens. And I was shocked because this kid had never taken an econ class in his life and he knew that shift happens. There's bumper stickers, although most of the bumper stickers I've seen, they misspell it. They misspell shift. Anyways, but shift happens. Okay. And one of the things we're going to find out in this course is that every time I introduce you a curve, a new graph, we're going to shift it. And you always have to know why it shifts because it doesn't really just happen. There's actually got to be something that causes it to happen. Okay. And for a production possibility curve or production possibility frontier, the three things that cause it to shift are changes in resources. Again, what do I mean by resources? I mean land, labor, capital, and entrepreneurship, changes in technology, or changes in human capital. So let's suppose we're on this production possibility curve and we're sitting right here. Okay, here's our production possibility curve and we're right here. The only way we can move out to this, that's the red one, the only way we can move up to the blue one or move beyond that green dot, anywhere beyond the red line, is if we find more resources or we find better technology for the resources we have, or our workers become more productive. And workers become more productive have to be human capital. You can't hire more workers because what a production possibilities curve says is a production possibility curve tells you how much you can possibly produce. If we're producing A and B, how much you can possibly produce given your fixed resources, given your fixed technology, given your human capital. If you have more of any of those things available, then you're not on your production possibility curve. And in fact, we say that this point out here is unobtainable. This red point out here is unobtainable because it's beyond the production possibility curve. Why is it unobtainable? Because we don't have the resource, technology, or human capital. If we get them, then the curve would shift. The other thing we say is that a point inside the curve, like this, is inefficient. If you're producing on that point right there inside the curve, then you're inefficient. You have unemployed resources like unemployed land, unemployed labor, unemployed capital. Entrepreneurs aren't starting new businesses, things like that. So you're not producing what it's possible to produce. See, the line is the production possibilities curve. Okay, sorry about that. I had to get a drink of water. So anytime the curve shifts, we call that economic growth, the ability to produce more economic growth, and that's shown by an outward shift of the PPC. PPC curves can also shift inward. All right. Right now, Russia and Ukraine are at war. What are they trying to do? One of the things they're trying to do is bomb each other's factories. Because if I can destroy another country's factory, then their production possibilities shifts in. So we go from this production possibility curve here to this production possibility curve here. The curve shifts in, our ability to produce decreases. Okay. New topic. Comparative advantage in trade. All right. So what we're going to do here is we're going to look and see, put some math to this to show why do different people, countries, states, um, uh, um, companies do produce what they produce. Okay. So, for example, Ford is really good at making cars and pickup trucks. Why don't they make water bottles? Well, because if they make water bottles, they can't use that same factory to produce cars. There's an opportunity cost here. So what they need to do is they need to do what they're good at. They should not, split out into the the water bottle making, you know, entry. And sometimes you'll see fast food restaurants do this. Fast food restaurants, like you'll get a burger chain that's really good at making burgers. Then they'll say, "Hey, we need a chicken sandwich," and usually that chicken sandwich doesn't go over as well. Okay, they're using those limited resources, limited land, labor, capital, entrepreneurship that they have to try to produce another product that they're just not good at it, right? And this is what we're going to be calling a comparative advantage. You do what you're good at, type thing. All right, so when you get a comparative advantage question, we'll come back to trade in a little bit right now for the comparative advantage, the next advantage. If you do a comparative advantage question, the first thing you got to do is you got to figure out, is this what we call an input problem or an output problem? Okay, an input is what goes into the production process. It can be hours, it can be units of factory, it can be units or units of a capital, it can be labor, like I said, labor hours, things like that. Okay, it's input. And you'll see. I'll give you more examples in a second here. An output is what you get out of what's produced or what's done. And I say what's done or what's produced because these aren't all just businesses producing stuff. We're going to use other examples here. Okay, so let's go through one. For example, miles per gallon. Okay, well, what's the input in miles per gallon? What's the 1 gallon of gas? What's the output? How many miles the car can travel? So the input is the 1 gallon of gas, and the output is the miles. Okay. Whenever it's the output that can change, that's an output problem. An output problem is one where the output changes and the input is fixed. If we're going to compare, your car to my car. We're going to compare 1 gallon of gas. We're each going to put 1 gallon of gas in there. We're going to see how far you can go. We're going to see how far I can go. Okay. That's an output problem. Pieces of gum per dollar. I go to a store. How many pieces of gum can I get per dollar? What's the input? The single dollar. What's the output? How many pieces of gum I can get? At different stores, you can get different numbers or pieces of gum. And that's what we call an output problem. An input problem is one that the input changes. So an example, hours to a job. What's the input? The hours, the plural hours. You're going to get 1 job done. That's the output. Apples to make a pie. What's the input? The apples is the input. The pie is the output. Now, one of the things people will often say that, but wait, a pie that has 7 apples is better than a pie of 6 apples. No. One of the assumptions we make here is called ceteris paribus. One of the assumptions we make is that the output is the same whenever you have an input, whenever you're looking at an input problem. Okay. The job, if you take 2 hours to do the job and I take 3 hours to do the job, when we're done, the job is the same. The satisfaction for whoever's doing it, whatever, is the same. In other words, the job is done and it's done well, whether it took 2 hours or 3 hours, right? And so the pie is the same, whether you took 5 apples or 6 apples to make the pie. It's still the same pie. You get the same output. Then you have to start thinking about waste and things like that. And that's exactly what we're getting into when we talk about this. So, all right, so what we're going to do now is we're going to talk about what we call absolute advantage. You can notice over here, I was using the term comparative advantage. I haven't taught that yet, okay? The main topic is comparative advantage, but in order to do comparative advantage, the first thing you have to understand is input or output. The second thing you understand is something called absolute advantage. Okay. Absolute advantage is just strictly who can do the most. That's all it is, or who can do the best. All right. So what I've got here is got an example. I've got two people here. I've got Ted, I've got Nancy, and this is their factories. Ted has in his factory in an hour. So we're looking at tons per hour. So these numbers are in tons here. In an hour, Ted can produce 70 tons of milk, or he can produce 15 tons of cheese. Now he can actually produce somewhere in between those. Nancy in an hour can produce 40 tons of milk or 45 tons of cheese. Now I say or because there's an opportunity cost here. They can't produce both of those. What I'm actually giving you here is numbers for a production possibility curve. Okay, this is how much Ted can possibly produce. He could produce way up here and produce 70 tons of milk and zero cheese, or 15 tons of cheese and zero milk. Yes, he can produce 35. What would that be? That would be 35 and 7.5 tons. Yes, he can. He can produce at that point right there. Okay. But what we're worried about, we're not worried about, anywhere he is on this curve. What's going to happen? We're going to find out that he should actually specialize and produce either milk or cheese, and let Nancy specialize and produce milk or cheese, and then they should trade with each other. So for Nancy, it's 40 milk and 45 cheese. So it is 40 milk and 45 cheese. Okay. So looking at this, let me erase this here. Well, I'll go back to the numbers first. Okay. Looking at this, absolute advantage is just who can do it the best. So who can do the best in milk production? Well, Ted can. Okay, now here's a gotcha for the free response question. Let's suppose the free response question says, who has the absolute advantage in milk? Explain. So think about your answer. Who has the absolute advantage in milk? Explain. The answer is Ted. I already said that, but the explain point, most of you miss it. Okay, when I do this in my class, I make them say it or write it down. Almost everybody misses it. People want to say because Ted can produce more than Nancy. Okay, that's great. That you just defined absolute advantage, but you didn't solve this problem. Anytime a problem gives you numbers, you have to use the numbers in the explanation. A little bit later on, there's going to be a problem in this class that you're going to do, and a lot of y'all are going to lose points because you're not going to use the numbers in your explain. The answer is, who has the absolute advantage in milk? The answer is Ted, because 70 is greater than 40. Now I know you are comparing Ted's output tons per hour of milk versus Nancy's output in tons per hour, which is 40. And if this was a free response question, that's all you would have to say. That would answer the question. You'd have to say, the question was, who has the absolute advantage in milk production? Explain. The answer, Ted, 70 greater than 40. The 70 greater than 40 is actually your explanation. You don't have to write it in sentences. Now, probably would be best because Ted can produce 70 units in an hour and Nancy can only produce 40. That's probably the best way to write it, but you don't have to. This is called technical writing. Okay, I'm gonna have to teach you all that. Definitely do not write paragraphs. You ready to hear what I'm saying? Do not write paragraphs. Just answer the stupid question. Okay, who has the absolute advantage in cheese production? Obviously, the answer is Nancy, because 45 is greater than 15. So for cheese production, it's Nancy, because 45 is greater than 15. That's your answer. Okay, that's absolute advantage. So take a look at this one real quick. Okay, we can give it to you in production possibility curve form, and now you're comparing Ted's milk production to Nancy's milk production, and Ted's cheese production to Nancy's cheese production. So you do the exact same thing. It's just Ted has the absolute advantage, can produce 70 versus 40 for Nancy. Nancy has the absolute advantage in cheese production because she can produce 45 to 15. So we can give it to you in either table form or this, or they may actually give it to you in word form. They may give you a word problem that tells you what they can do, and now you got to be able to read it. So those are 3 different ways that this will be presented to you. Now, take a look at this one. This is an input problem. So this is hours to build. So who has the absolute advantage in car production? See if you can solve it. Who has the absolute advantage in car production? And the answer is company X. Company X has the absolute advantage in car production because 2 hours is less than 3 hours. Would you rather spend 2 hours doing your homework, or would you rather spend 3 hours doing your homework? If you spend 2 hours and you get a 100, and your friend spends 3 hours and gets a 100, you had the advantage because you got the 100 with just 2 hours of work versus 3 hours of work. Be careful, input problem versus output. We know this is an input problem because it's hours to build. The input is the hours, the output is what you build. So obviously that these guys have the absolute advantage in car production, and company Z has the absolute advantage in tank production. Next, comparative advantage. That's where we're getting to. We're trying to get to this stuff here. Comparative advantage is we're going to compare the opportunity cost of one to the opportunity cost of another. So we can compare the opportunity cost of Ted milk production to the opportunity cost of Nancy milk production. We're going to compare the opportunity cost of company X's car production to company Z's car production. We're going to compare them, and the one with the lowest opportunity cost has the comparative advantage. The one that has the one that has to give up the list. Remember, opportunity cost is what you give up. The one that has the lowest opportunity cost has the comparative advantage. So let's go back to good old Ted and Nancy here. All right, we already decided that Ted has the absolute advantage in milk production. Nancy has the absolute advantage in cheese production. But what about comparative advantage? Okay, now I can tell you just a quick little trick here. If they're opposites like this, then the comparative advantage will always go with that. So this would be comparative. Ted will have comparative advantage in milk, Nancy will have comparative advantage in cheese. Okay, but what if it said explain? If it said explain, you can't say that. You have to show it in math, or it said calculate. So what we're going to do is we got to compare. Ted can produce 70 milk, 15 cheese. Nancy can produce 40 milk and 45 cheese. We have to compare the production of each here. You can't do it with these numbers. So what we're going to do is we're going to do a little bit of math voodoo, okay, also called algebra. We're going to do some math voodoo to figure out the opportunity cost of 1 unit of milk. And trust me, if you'll do it this way, you'll get it right. Again, there's a free response question coming up in this class that some of y'all are not going to do it this way and you're going to miss it. All right, let's do Ted first. For Ted, for every 70 units of milk that he produces, he could have instead produced 40 units of cheese. So his opportunity cost of 70 milk is 40 cheese. But we want to find out what is the opportunity cost of 1 milk. So what do? How do we get rid of that 70 if this is an algebra problem? We divide each side by 70. So this becomes 70 over 70 milk is equal to 40 over 70 cheese. Because if you divide the left side by 70, you have to divide the right by 70, because that's what they tell you in your math class, right? So what this is that for every, oh, wow. Take a look what I did, guys. Major mistake. Major mistake. Take a look at it so you can figure out what I did wrong. Major mistake. I wish I could say I did this on purpose. I was just working too fast. One thing, well, let me tell you the mistake first. I used Nancy's milk production. I needed to use Ted's cheese production. So this is supposed to be 15 cheese. This is supposed to be 15 cheese. And this will be 70 15ths of a cheese. Okay. One of the things is that the way this thing is organized with Ted and Nancy on the left and milk and cheese on the top, they can also show you the exact same thing and put Ted here and Nancy here. And then this could be milk and this could be cheese. And if you do that, then you would be reading this way for Ted. Okay, so you got to be careful. Ted, in the way I have it here, is milk and cheese, But if I erase all this, then you got to be careful how you read it. And TED is 70 milk is equal to 15 G's. Okay. Now, reduce the fractions, of course, if you can, reduce the fractions. You're allowed to use a calculator on the AP exam, so I strongly suggest you poke that in. But I'm going to show you that to answer this question about who has a comparative advantage, you don't have to do that. Okay, what we have to do is we have to compare Ted's production of one milk, which is, well, I'm going to just keep it 7/15ths because I'll mess up the math. I'll get my calculator. We have to compare it to Nancy's production of one milk. So what we do with Nancy, we say that 40 milk is equal to 45 cheese. How do we get one milk? We divide each side by 40. 40 over 40 milk is equal to 45 over 40 cheese. So for every one milk she produces, she gives up more than one cheese. For every one milk, still did this thing wrong. I got flustered and I did this wrong. You divide each side by 70. Boy, oh boy, I'm not making a good first impression in my 15/70ths. 15/70ths. Because if you divide the left side by 70, you can divide the right side by 70. Right? So this is 15/70ths. So for Ted, every unit of milk that he produces, he gives up less than 1 unit of cheese. For Nancy, for every unit of milk she produces, she gives up more than 1 unit of cheese. Comparative advantage is the one that can do it with the lowest opportunity cost. The lowest opportunity cost. So who has the lowest opportunity cost? Who gives up the least to produce 1 unit of milk? Ted. So Ted has the comparative advantage, which is exactly what I told you. Since he has the absolute advantage, and she has the absolute advantage in cheese, he's going to have the comparative advantage. That's the way it's always going to work. Okay, but I proved it with the math. Now, what if I said who has it in for cheese? Okay, just real quick, if they do this, because what they'll do is it's a 5 answer, 5 multiple choice question, 5 choices for each multiple choice, and they'll say, A and B might be in terms of one milk, and C and D might be in terms of one cheese. But you don't have to sit here and rework this. Okay, it's always a reciprocal. So one cheese for Ted is going to be 70/15ths of a milk. You just flip this up guy over. And therefore one cheese over here is going to be 40/45ths of a milk. So who has the comparative advantage in cheese production? Nancy. Why? Because her opportunity cost of one cheese is 40/45ths of a milk. Nancy's opportunity cost of one cheese is 70/15ths of a milk. If this was a free response question and you didn't reduce it, they would not take points off. You'd just get full credit, even though you didn't reduce it. If it was a multiple choice question, the answer choices, of course, would have been reduced. Just so you know that, but use a calculator on the test and reduce it, just to be safe. Use a calculator on the test and reduce it. Okay, so that is comparative advantage for an output problem. Okay, now for an input problem, Gabs is going to teach this to you differently the way I'm going to teach it to you. Okay, if you watch the different videos for different people, Jason Welker or Jacob Clifford, I'm not sure how they do it because I've never watched them solve this, but I'm telling you, my way is easier. Okay, I've had students that learn one way, and then when I showed them my way, they're like, "Oh my goodness, why did they not show us this?" I'm telling you, my way is easier. Okay, you don't have to memorize anything. You just do it the same way as we just did. But what I do here is I just convert it to an output problem. Okay, this is hours to build. You're building one car or one tank. If it takes 2 hours to build, what I want this to become, I want it to become number built in 1 hour. I want to make it 1 hour is your input. Number built is now an output problem, right? So what I'm doing is changing this to an output problem. And what I do is I go to Company X. I say, hey, Company X, it takes you 2 hours to build a car. How many cars can you build in 1 hour? And they go, duh, only half of a car. Company Z, it takes you 3 hours to build a car. How many cars can you build in 1 hour? And they go, oh, 1/3 of a car. Company X, how many tanks can you build in 1 hour? If it takes you 2 hours to build a tank, well, I can only get a half a tank done. And company Z can still do one full tank in the hour. We now have number built in 1 hour. It's now an output problem. The disadvantage of this is you then have to deal with fractions, okay? And some people don't like fractions, but again, you have your calculators if you need them. That's new. If you can use a simple calculator, you can't use anything that stores memory, but you can use a simple calculator on the AP exam. So we do this. So let's solve for this. Figure out the comparative advantage for company X. Well, if a half of a car is equal to a half of a tank, that means for every one car they produce one tank. And let's see. Okay, because it's just reciprocal, right? Just you multiply it side by two. For company Z, it's a third of a car is equal to, one tank. So we've already solved for tanks. So before I move on, who should produce the tanks? Well, the one with the lower opportunity cost. A third is lower than one, so company Z should produce, this is a Z, company Z should produce the tanks. What about cars? Remember, this is always typical. One car is equal to 3 tanks. And now we can compare the one car here to the one car here, and it looks like these guys here should produce the car. Company X should produce the cars. And what you do is you produce what you have the comparative advantage in, and then you specialize and trade. Okay, and this is the way the world works. At my school, I'm retired now, so I'm just teaching online now, just for the fun of it. But when I was at my school, I taught there for 32 years, and I've been teaching AP Economics since 1996. And I asked the students, I said, you know what? Why don't I teach AP Psychology? And they go, well, because Miss So-and-so teaches AP Psychology. I said, yeah, but I was actually teaching psychology before she got here. I was actually the psychology teacher. I was teaching AP Economics and Psychology. We didn't have AP Psychology back then. And when the AP Psychology class came out, they asked me, they said, Mr. Patmicky, do you want to teach AP Psychology? And I said, no, I don't want to teach AP Psychology. And they said, why not? I said, because I'm the AP Econ teacher. And they said, you can do both. And I said, no, I can't do them both well. Because for every minute that I spend worrying about my AP Psychology class, that's a minute I can't be worrying about AP Economics. When I watch a movie, I'm thinking, how can I use this movie as an example in my class? If I was teaching AP Psychology, then I'd be worried about both things. See, there's an opportunity cost associated with both. Not only that, but I can't produce them both at the same. I can't teach them both at the same time. Imagine I've got a classroom and half of them are learning AP Psychology, the other half are learning AP Economics. That'd mess with your head, wouldn't it? If I was in there trying to teach economics when you were trying to learn psychology and vice versa, I can't do them both at the same time. There's an opportunity cost associated. So you do what you're good at. You do what you're good at. You specialize and trade. Okay. Now, I had in here what are your questions, just in case people are online here, but I'm gonna go a little step further here. Let's talk about terms of trade. This is not a major topic, but it is something you need to know that could throw a question at you. Absolute comparative advantage, guys, guaranteed on the AP exam, 2 to 3 questions. Guaranteed, sometimes it's even an FRQ. Guaranteed 2 to 3 questions between absolute comparative advantage and that. And like I say, sometimes it's an FRQ. Terms of trade. Terms of trade is now we're going to specialize and then we're going to trade with each other. So back here, we know that Ted's factory is going to produce nothing but milk. Nancy's factory is going to produce nothing but cheese. But Ted still wants to buy some cheese and Nancy still wants to buy some milk. So what they're going to do is they're going to trade with each other. They're not going to buy it. In the real world, you use money to buy stuff. But here, what they're going to do is they're going to trade milk for cheese. They're going to trade with each other. How much they trade is called the terms of trade. Okay, so basically what you do is you produce the maximum of the good that you have the comparative advantage in, and then you trade for what you need. Do they have cars in Florida? And the answer is yes, of course they have cars in Florida. Do they produce cars in Florida? No, there are no car factories in Florida. As far as I know, there are no car factories in Florida. Do they have oranges in Detroit? Yes, they have oranges in Detroit. Does anybody commercially grow oranges in Detroit? And the answer is no, because the winters, you can't grow oranges in Detroit, but yet they have oranges. Well, how do they do that? Because they produce cars in Detroit and they trade them for oranges. Florida produces oranges and they trade it for cars. Why do they do it that way? Because of comparative advantage, absolute and comparative advantage. Florida has the absolute advantage in orange production compared to Detroit. Detroit has the absolute advantage in car production compared to Florida. Uh, and the reason for that is the climate for growing oranges. But then you say, well, why can't Florida produce cars? Because the expense of heating a huge factory like that. They're better to produce them up there where it's cooler. That's kind of one of those things that happens. And then they do produce cars in Georgia, which is kind of an interesting thing. But that's because of our low minimum wage. We've stolen a lot of business. You know, the movie industry. There's a movie industry was used to be non-existent in Georgia, and it's now in Georgia because our minimum wage is $7.50 an hour, and California's minimum wage is $15 an hour. And so no company wants to pay 15 when they can pay 750. It's cheaper for them to hire to move the big the actors around than it is to pay for all those small people, minimum wage folks there. So anyways, that's just a quick little absolute comparative advantage question here. All right, so let's go. Let's suppose we've got two countries, United States and Mexico, and they're trying to produce either wheat or coffee. So the first thing you got to do is you got to understand that the United States can produce either 30 coffee or 30 wheat. They cannot produce both because if you think about it, they've got this area here. If they produce 30 coffee, they use the whole area for coffee. They can't produce any wheat. If they produce the whole area for wheat, then they can't produce any coffee. So right off the bat, who has the absolute advantage in coffee production? Well, the United States, because they can produce 30, where Mexico can only produce 20. Who has the absolute advantage in wheat production? The United States, because they can produce 30 and Mexico can only produce 10. So should the United States just produce nothing? Should the United States trade with Mexico? And the answer is yes. One of the key things about economics, no matter what the news media, the politicians tell you, everybody benefits from voluntary trade. Everybody benefits from voluntary trade. The fact that, in your city, do they produce cell phones? No, but yet you still have cell phones. How did you get them? Trading. Your city produces something. Okay, even if it's a little small town. I live right outside of a really, really small town, but it's got restaurants and things like that. It does, two. Actually, it's got one restaurant. One restaurant doesn't have a stoplight. But anyways, it's got a police department, a library, and a little small restaurant. But anyway, so it produces something and it trades for everything else that it needs. So the idea here is that Mexico and the United States should specialize in what they have the comparative advantage in and then trade for it. So what we've got to do is we've got to run the numbers here. I'm running 10 more minutes. I can get this done. All right. So for the US, this one's easy. For every 30 coffee, they could have produced 30 wheat. So that means the opportunity cost of one coffee is one wheat. For Mexico, for every 20 coffee, you get 10 wheat. So what's the opportunity cost of one coffee divided side by 20? It's a half of a wheat. So if we go the other way, for every one wheat, it's going to be two coffee. Now what we do is we compare them to figure out who should produce coffee and who should produce the wheat. Well, the opportunity cost of producing coffee for Mexico is a half of a wheat. They give up a half of a wheat. The United States gives up a whole wheat. Well, the world would rather lose a half of a wheat by Mexico producing the coffee, so they produce the coffee because the world loses a half of a wheat every time Mexico produces coffee. If the United States produces the coffee, the world would lose a whole wheat. And then, so if they're producing the coffee, if Mexico's producing coffee, who produces the wheat? The United States produces the wheat because their opportunity cost is one coffee. Every wheat they produce, the world loses the ability to produce one coffee. If Mexico did it, the world would lose two copies. So what's going to happen is they're going to specialize and trade. Now, how much should they trade? This is what we call the terms of trade. Okay, the terms of trade is the rate by which one unit of good is traded for another unit of good. Right? If you're at lunch and you've got a sandwich and your friend has chips, and you say, hey, let's trade sandwich for chips. Okay. So let's talk about for a half of a sandwich. You've got the sandwich. You've got half a sandwich. Okay. Let's do it in whole. Let's just make it easy. Let's say one sandwich, just because we always solve for one here. Let's say you've got this sandwich. You want to trade for chips. Well, how much chips do you want? We want them all. How much chips do they want to give you? As little as possible. So the one that's giving always wants to give as little as possible. The one that's getting always wants to get as much as possible. So right here, when we do go back to Mexico and the United States, who's in terms of one coffee, Mexico wants more than half a wheat. They want more than half a wheat. Let me erase this down here because it gets confusing. They want more than a half a wheat because if the United States offers them just a fourth of a wheat, then they can do it on their own for half a wheat. So they're not going to do it. The United States is giving away wheat. They want to give away as little as wheat as they can. So what we do is we find out the terms of trade. I'll do TOT for terms of trade for one coffee is going to be somewhere between half of a wheat. It's going to be between a half of a wheat, which is what Mexico, the minimum Mexico would accept, and one wheat, which is the maximum the United States would give away. The most we will give away is one wheat. The least they will accept is a half a wheat. And guys, when you do terms of trade, it really is this easy. It's just between the two numbers here. All right. If you go back to this, in terms for one car, the terms of trade is going to be between one tank and three tanks. For one tank, it's going to be between a third of a car and one car. Back over here, Ted and Nancy trading cheese and what was it? Cheese and milk. So for one milk, the terms of trade are going to be somewhere between 15/70ths of a cheese and 45/40ths of a cheese. For one cheese, it's going to be somewhere between 40/45ths of milk and 70/15ths of a milk. Terms are going to be somewhere between there. So when you do a terms, now where does it actually end up? That's what students always ask me. Where does it end up? That's where negotiations come into play. Okay, that's the political part of this. Is that if one of the things that President Trump is saying is that we're not getting a fair trade with these other countries. Okay, what he's saying is that the terms of trade favor them more than it favors us. We're both winning. That's the thing about it. Everybody benefits from voluntary trade. And there is no argument that sometimes negotiations are done where one person, country, factory, state, whatever, whoever it is you're talking about, benefits over the other. What it really comes down, because again, we don't actually trade wheat for coffee. We trade for money. We use money as the transaction. So, all right, that is it for this evening. It's actually 5 minutes early, but I always leave room for questions. I'm going to stay on for 5 more minutes just in case somebody just happens to come on. I'm supposed to be on for a full hour. So I'm going to stay on for the full hour, and I will keep the recording running for another 4 minutes because I'm supposed to keep it on for a full hour, but I'm not going to sit here and say anything because there's nobody asking questions. So that's going to be really awkward with the recording running. It's a little bit about me. Like I said, I've been teaching. I taught for 32 years in the same school. I taught in the same classroom for 18 of those 32 years. I used to tell my students that they were like, "Are you kidding me? That's older than me." Yes, it is. It's older than a lot of you guys are. So same classroom for a long time. I've been teaching AP Economics since 1996. I love it. I gave up teaching because not gave up teaching. I gave up face-to-face teaching because I just enjoy being off more now. I used to enjoy work more than being off. I used to, on a Sunday night, be super excited about going to work the next day. And I never got to the point where I didn't want to go to work the next day. But I got to the point where not, I was like, oh man, I wish I had another day off. Not because I didn't want to go to work, but because I wanted another day off. And that's when I knew it was time to retire. Um, you see professional athletes hang on for long periods of time after they reach their peak, and I think I had was getting there where I hung on much longer. I wasn't going to be at my peak anymore. I wasn't going to be as good in the classroom because I enjoyed my time off. Today I played in my greenhouse. I went outside, did some stuff, and uh, graded papers. Didn't grade a lot of your papers and that, but anyways. All right, it is 5:57, almost 5:58. I'm going to go ahead and call it quits. Stop sharing here. I hope you guys have a great whatever it is, whether you're watching this late at night or early in the morning. So I put my hood on because I get cold because I don't have any hair here. But anyways, hope you guys have a great evening, day, whenever it is you're watching this. I appreciate you sticking in to the end, and I will talk to you later.